Okay, so now that we've gone over some of the notes for the area and perimeter polygons, we're going to do some problems. So we have number 4, which states, John is repainting a free throw key of a basketball court. The free throw key is made by combining a rectangle and a semicircle as shown below. In order to know how much paint to purchase, Jim will determine the area of the free throw key. What is the total area to the nearest whole square foot of the free throw key shown in the diagram? Use 3.14 for pi. So there's a couple things that's going on in this problem. Before we actually start, we're going to highlight or underline some key terms. So on the side here, I have some key terms that I've already written out. So you can find these terms in the problem. The first one that I have is rectangle. So we know that our problem or our figure is made up of a rectangle. We also know that it's made up of a semicircle. And then the last thing that we have down here is that we want to know how much paint we need to use. So it says we need to determine the area of this figure that's given, right? So now that we have this information, the first step that you guys should do is first, of course, draw out the picture. So yes, the picture is already here, but when you take your tests, you're not able to draw on the actual computer screen. So the best bet is for you to actually draw out the figure. So step 1, we're going to draw the figure. But instead of drawing the whole figure, we're going to break this figure into pieces. So we know we have a rectangle, and we're going to start with that piece first. So we're going to draw our rectangle. So we have a rectangle. Now that we have the rectangle, we're going to go and actually label the given information. So the information that's given is that we have 12 feet here as our height, and we have 19 feet here as our base. So if we know we're dealing with area and we have a rectangle, then we can reference our reference sheet to find the actual formula for the area of a rectangle. So if we look on our reference sheet and the area where it says area, we're going to locate which formula to use. So obviously we're not dealing with a triangle, trapezoid, circle, or regular polygon, but we have this word here, parallelogram. So remember, referring back to the vocabulary that you've learned at the beginning of the school year, parallelogram refers to a figure that has 2 pairs of parallel sides. So rectangle falls within that category, so of course we're going to use the formula A equals BH. So now that I have my figure drawn, and I know I have the area, I'm going to label the area of the rectangle so I can remember what I'm finding the area of. So remember, area of a rectangle is B times H. We know our base is 19, and we know our height is 12. So I'm going to take my calculator, and we're going to go ahead and calculate what that is. So 19 times 12, that gives me 228. So we have 228 feet, and remember, feet squared because we're dealing in terms of area. Okay, so now we have the area of our rectangle. So now we have to move on to the second piece. So we've done this piece already. So now we have to move on to the second term, which was the semicircle. So let's draw this out. And we have our semicircle. And let's label what we have. So looking at the figure here, we know the base was 19 feet. But let's look at this semicircle. This semicircle is part of the actual rectangle. So if we knew that the base was 19 feet and we knew that the height was 12, if the height is 12 on this side, and we know that this is a rectangle and the properties of a rectangle are that opposite sides are congruent in this term, in this case, opposite sides, the measure of the sides are equal. If this is 12, then we know that this piece also has to be 12. So if that's 12, then I can label this right here as being 12 feet as well. Now, because we're dealing with a semicircle and we're dealing from the length from one end of the circle to the other end through the center, and we know a semicircle is half of a circle, then I can call this my diameter. Okay? So now that I have my circle, my semicircle drawn and labeled, we can refer to our reference sheet. So on our reference sheet, it doesn't indicate semicircle, it just indicates circle. So for a full circle, we know that the area is A equals pi r squared. But because we're dealing with a semicircle, we know that we're dealing with half of the circle. So I can alter my formula a little bit. So we're going to say A, the area of the circle, is equal to pi r squared. And because we're dealing with a semicircle, we're going to divide that by 2. Okay? So now that we have our formula, we can now just start inputting information. But before we do, let's look at the formula. The formula indicates that we are using r. And remember, r is radius. You can also find that on your reference sheet, if you forget what r is, as the radius. Remember, the radius is half the diameter. So the radius starts from the center of the circle to one point on the circle. So if our diameter is 12, then we know that our radius is half of 12, which is 6. So we know the radius is 6 feet. So since we know our radius is 6 feet, we're going to just go ahead and plug in. So we have pi times 6 squared over 2. Okay? Now, in the problem, because let's go back, it says use 3.14 for pi. So I'm just going to go ahead and rewrite 3.14 times, we know it's 6 squared is 36, and divide that by 2. So we're going to come back up here. So now I can use my calculator to plug it in. So the calculator can do everything for you. You don't have to worry about steps. Just make sure you use grouping signs if you're going to use them. So we have 3.14 times 36, which gives me a total of 113.04. And then remember, we are dividing it by 2. So we divide by 2. And that gives me a total of 56.52. So 56.52. And remember, that is feet squared. So you're probably saying, okay, we're done. No, we're not. Remember, the problem came back. Let's go back to the problem. The problem says, what is the total area of the figure? So total to me means the sum, everything together. And sum, of course, means to add everything up. So now we're going to go and do our last step. So we're going to say A, and we're going to call this total, so I can remember what I'm doing. The total area would be the area of the first figure, which was our rectangle, which is 228 feet squared, plus the total of our second figure, which was our semicircle, which is 56.52. So in my calculator, I already have my 56.52 saved, so I don't have to redo that. I'm just going to add 228 to that, and that gives me a total of 284.52. So 284.52, remember your units, feet squared. Now, you're probably saying, we're still done. No, we're not, because if we look back at the problem, it says, what is the total area to the nearest whole foot? So that means we have to involve rounding. So if we're looking at our answer that we got here for the total, we have 284.52 feet squared. If we're looking at to the nearest whole foot, I'm looking at my place right here, my ones place, which is the 4. And anything that is to the left of the decimal represents whole numbers. Anything to the right of the decimal represents a decimal, or less than the whole number. So when we round, we have to look at the number that comes before the number that we're rounding to. So we're looking at our 5. This is the number that's behind our 4. If we know that the number is 5 or more, we round up. If it's less than 5, we stay. So as you can see, the number after 4 is 5 or greater. So we know we're going to move, we're going to round this 4 up to the next number. So we know that our total area is equal to 285 feet squared. And that represents our final answer for this problem.